Hello everyone, in this video we're going to learn about exponential functions. The simple one is of the form y equals a to the power x, where a is known as the base and x is known as the exponent or sometimes index. There are many practical situations where these type of functions can be applied, including radioactive decay and population growth. And first of all, we're going to see what happens to this function when for different values of a. Let's take a simple example when I equals 2. Let's have a look at the function. So this is continuously increasing. So that's a function which is strictly increasing. So what is the value of a in that one? So a is greater than 1. So if a is greater than 1, the function is strictly increasing. And what happens when a is smaller than 1? So which I'm going to take as y equals 0.5x. So that's a function which is strictly decreasing. So if a is less than 1, and how much it can go? It can go up to 0. Okay, so if a is 0, between 0 and 1, the function will be strictly decreasing. So now a natural question would be whether a can take negative values. What happens if a is negative? So let's have an example. So y equals minus 2 to the power x. So a is minus 2 in there. So what will happen there? If I'm putting x equals 1, so this function becomes y equals minus 2 for x equals 1. And for x equals 2, what will happen? So minus 2 to the power 2, which is y equals 4. And x equals 3, what happens? Y equals minus 2 to the power 3, which is minus 8. So this will keep on going, positive and negative. So this is not the simple exponential function format. It's not increasing or it's not decreasing. So we don't want a to be negative. And what's other value which we haven't taken? A equals 1. Can a equals 1? What will happen if a is 1? So y equals 1 to the power x. No matter what value of x you choose, x equals 1, 2, 1000, 100. So whatever value you take, this has only one single value. So this will be a function which is constant throughout, just a straight line. So we don't let a equals 1 as well in this function. So a is any positive real number except 1. So that's the possible values of a. And so one little thing which I didn't say here is we took y equals 0.5x. Is there any other way we can write it down? So if I'm looking at carefully, 0.5 can be written as 1 on 2 to the power x. So this is nothing but, if I expand this bracket, it's 1 to the power x on 2 to the power x. And 1 to the power x is 1 on 2 to the power x. Okay, so 2 to the power x, 1 on 2 to the power x is nothing but 2 to the power minus x. It's one of the index rule. Okay, 1 on a to the power m equals a to the power minus m. So this is nothing but 2 to the power minus x. So now you can compare those two graphs in there. Y equals 2 to the power x and y equals 2 to the power minus x. They are reflection of one another about the y-axis. So another thing which might be interesting for these type of graphs is to know what is the y-intercept of this function. So y-intercept is when you put x equals 0 in the function. So if you put x equals 0 in this one, a to the power 0 is 1. Okay, any number to the power 0 is 1. So no matter whatever value you choose, 200 or 5000, whatever value you choose, the y-intercept is always going to be 1. Okay, and one more specific point could be when x equals 1. So when x equals 1, this function becomes a to the power 1, and any number to the power 1 is that number itself. So if you're looking for y equals 2 to the power x, it's x equals 1 gives it 2. And if y equals 100 to the power x, at x equals 1, the function will be having a value of 100. This is another point of interest in this one. Say x equals 0, y-intercept, and what happens when x equals 1. Okay. So as with any other function, it will be nice to know what is the domain and range of an exponential function. So domain is actually the values or the possible x values. So if you look at two functions, y equals 2 to the power x, y equals 2 to the power minus x, in those two, you can see that there's no limit, there's no limitation for the value of x you can put. So it can go from any positive real numbers, negative real numbers, or positive. So x can take any value. So it can take from minus infinity to plus infinity, unless there's some other restrictions are there. Okay. And how about the range? So the range is the possible y value. So you look at those two functions, what's happening to the y value? It never goes to the negative axis, right? It doesn't touch the x-axis. Or y equals 0, is it possible? Okay, let's have a look. So what happens in y equals 2 to the power x? What happens when x is a large negative value? So let's put x equals minus 100. It's a sort of large negative value, and y equals 2 to the power minus 100, which is 7.9 times 10 to the power minus 31. So this minus doesn't tell this is a negative number. Instead, it's saying you need to put the decimal place 31 places behind of this one. So that's 0.0000 something, now that number, which is a very small positive number, but again greater than 0. And what happens when x equals minus 1000? So y equals there 9.33 times 10 to the minus 302. So again, it is saying you have to put the decimal places 302 points behind. Okay, again, a very small positive real number. It's never touching the 0. Okay, so it's actually approaching the 0 line, y equals 0 line, but it never reaches that one. It never crosses that one or reaches there. So that sort of line is known as an asymptote. So in this one, the range is then, range can take only the values from 0 to infinity. The reason I put this bracket in here is 0 is not included. If I put a square bracket, that means that 0 is included. But in this one, I put this bracket, so which means 0 is not included. So it can go from 0 to infinity. Or in this case, the x-axis is the horizontal asymptote. Even if it's a y equals 0.5x or 2 to the power minus x, as x tends to infinity, so its only thing is at the positive side, it's approaching to 0. Again, it never reaches that one, but only approaching 0. It never ever crosses the 0 axis. Okay, so that sort of line is known as the asymptote. And in this one, for this function y equals 8 to the power x or y equals 8 to the power minus x, this asymptote is the x-axis itself. So when there is a term added to that or multiplied in here, this could change, but I'm just talking about the simple functions of the form y equals a to the power x. Okay. One last thing about these sort of functions, the exponential functions, is it's a one-to-one function. So any value in range, you can only find one value in the domain. If you're mapping the values of domain and range, so you can find only one relation between these ones. So these are one-to-one function. So we mainly covered the fundamental things about this simple exponential functions, how this function varies with a, and what are the domain and range possible, and some other small properties of these ones as well, such as y-intercept.